Okay, let's dive into this. Welcome to the Explainer. Today we're unpacking an absolutely massive paradigm shift in how software is created. For decades, building an application meant you had to be a master of syntax, right? You were always fighting with semicolons, wrestling with server configurations, and banging your head against obscure error codes. But hey, that era, it's ending. We're literally moving from the age of the traditional coder straight into the age of the system architect. By taking a quick look under the hood at how large language models actually work, we're going to see how you can take a simple idea, use a scoping worksheet, and transform it into a crystal-clear, buildable app spec using just natural language.
Here's our roadmap for today's explainer. First, AI foundations under the hood. Second, the vibe coding revolution. Third, architecting your app spec. Fourth, eliminating the debugging loop. And finally, Ajath's parallel agent power. Understanding that technical foundation early on is totally key to effortless app building by the end of our time together.
All right, let's kick things off with Section 1, AI Foundations Under the Hood.
Now, before we actually start building, we need to understand how AI thinks. When you type a prompt asking an AI to build an app, it doesn't read strings of text the way you or I do. Instead, it relies on next token prediction. Basically, LLMs break raw text down into these tiny numerical chunks called tokens. Using algorithms like byte pair encoding, or BPE, it maps these chunks to numerical IDs. It's actually an incredibly elegant system. So, rather than storing a massive, memory-hogging dictionary of every single word form, it just splits words up, like the word unhappy gets cleanly split into two recognizable subunits, un and happy. Then, using a self-attention mechanism, the AI reads your entire prompt all at once, figures out the semantic relationships, and statistically predicts the very next token it should generate. It's literally building your code one calculated token at a time.
So, what actually determines how the AI chooses that next token? Well, it all comes down to a really crucial setting called temperature, which controls the sharpness of the AI's probability distribution. When you look at the higher temperature settings, like above 1.0, the AI takes big risks. It chooses lower probability tokens. Now that's fantastic for brainstorming, but man, it is terrible for coding. A balanced temperature of around 0.7 to 0.8 is your standard for a creative chat. But when we're generating application code, we need absolute consistency. That is why a temperature of 0 is absolutely essential for coding. T=0 triggers what's called greedy decoding, which basically means the model will relentlessly pick the single highest probability token every single time, making sure your code's logic stays perfectly intact.
Now, what's really interesting about this is a fascinating quirk of modern server-side physics. Even when you set that temperature strictly to 0 to get perfect consistency, it isn't perfectly deterministic. Since these massive models run on servers using concurrent batching, the GPUs are executing parallel threads. And due to something called floating point non-associativity, try saying that 3 times fast, mathematical operations processed in parallel don't always add up in the exact same order. So even at 0 temperature, you might see tiny, microscopic variations in the code it generates. Crazy, right?
Okay, moving on to Section 2, the vibe coding revolution.
Now that we've looked at that microscopic token level, let's zoom out and look at the massive shift we're all living through. Think about traditional coding for a second. It's syntax-heavy, demands an immense cognitive load just to memorize the rules, and frankly, developers lose days just fighting configuration conflicts and server setups. But vibe coding? This is a whole new world, backed by major players like Google Cloud. This is an era where anyone can just describe their vision using natural language prompts. You act as the creative director. You can literally deploy fully functioning web applications to production in a matter of minutes. The whole barrier to software creation has been completely smashed.
Next up, Section 3, Architecting Your App Spec.
So you might be wondering, if the AI is writing the code, what exactly is my job? Well, you are now the system architect. And the crucial point here is to use a scoping worksheet to turn an app idea into a clear, buildable spec. You absolutely must dissect your idea into 3 distinct categories. Let's call it the rule of 3 for app scoping. Step 1, user interface, or UI. Basically, what does the user actually see and click on? Step 2, database and backend schema. Where is that data stored and what are the fields? And step 3, business logic. What are the specific rules that connect the UI to the database to actually solve the user's problem? If you feed an AI a fuzzy, unstructured prompt, you're going to get fuzzy, broken code. But if you feed it this perfectly structured triad, it knows exactly what to do.
This structured approach fundamentally changes the game.
As you can see, vibe coding allows you to act as a system architect or creative director. By meticulously breaking your app idea down into those three categories, UI, database, and logic, you dramatically lower your own cognitive load. You don't have to hold the entire application syntax in your head anymore. You just focus on the layout, the flow, and your overarching vision. You are the director, and the AI is your production crew.
All right, section 4, eliminating the debugging loop.
You know, early AI app builders ran into a massive headache. Single chatbots would try to build front ends and then back ends, but they'd forget the context along the way and trap you in endless debugging loops. It was just the worst. The solution? A multi-agent architecture, like the one pioneered by Ajath. Don't think of this as a single AI chatbot. It's more like a highly coordinated construction crew. You have distinct agents, specifically Maya 4, Reina, Jacob, and Matt, and they all have specialized roles. Instead of one AI trying to do everything sequentially and losing its mind, these agents look at your structured spec and effortlessly divide the labor.
To put that into perspective, Ajath's system actually orchestrates up to 10 parallel agents concurrently. 10. While one agent is building your front-end layouts, another is over there configuring your databases, and yet another is setting up secure authentication, all at the exact same time. This parallel teamwork completely bypasses those repetitive debugging loops because the agents are perfectly aligned on the blueprint you provided, and they aren't constantly overriding each other's sequential mistakes.
And this brilliantly illustrates what that looks like under the hood. In the real world, this zero-setup infrastructure happens instantaneously. This back-end view proves the multi-agent coordination in action, showing those 10 parallel agents, including Maya 4, Reina, Jacob, and Matt, building your front-end, back-end, database schemas, and secure authentication concurrently. We're talking about real, production-grade infrastructure spinning up instantly, saving creators literally hundreds of hours of manual configuration.
Finally, let's jump into section 5, Ajath's parallel agent power.
So, where do you actually feed this well-structured spec to the agents? Well, modern platforms provide what's called an infinite canvas experience. You aren't just typing into a boring terminal anymore. You get zero-setup, full-stack hosting from day one. You get pre-configured databases and authentication straight out of the box. And crucially, it supports real-time visual tweaking. The agents actually tie visual components directly to your code, letting you visually tweak layouts while connecting to over 100 API integrations like Stripe for payments or OpenAI for AI features. Let's move to and see how this builds incrementally, because this workflow is a real game changer. With your three-part spec totally ready, that's your UI, your database, and your logic, you simply start with a visual layout right on the infinite canvas. You drop in the components, describe the vibe, and those parallel agents generate all the infrastructure underneath it incrementally. You review it, tweak the prompt, and expand. It is just this beautiful, seamless loop of creative direction and immediate, flawless execution.
So think about it. We've covered the underlying tokens, the absolute necessity of zero temperature for coding, the importance of scoping out your app, and the sheer power of parallel agents. Those traditional barriers, they are completely gone. Educators, entrepreneurs, non-technical founders, you now hold the power to build production-grade, full-stack applications simply by structuring your spec.
So what will you architect and build next now that the coding syntax barrier is permanently broken? If you're ready to take your scoping worksheet and turn your ideas into a live, shareable URL, it's time to put those parallel agents to work. Skip the dreaded debugging loop and start building your next big idea today over at learn.ajath.us. Thank you so much for joining me for this explainer, and hey, happy building!